Welcome back everyone. We'll continue with the session, workshop on digital technologies in the built environment. It's quite an interesting session, which will be started off by our lovely esteemed colleague here, Dr. Reno. I just say Reno the Lovely, because his surname Lovregio, but everybody calls him Reno anyway. He will start off, and then he'll be supported later on the Q&A session with Zenon, who is up there, and Daniel, who is on the virtual platform. Okay, over to you, Reno.
Yeah, thank you. So thank you for everyone that is online and who is physically present. Sorry if we started so late. We had a bit of a Zoom hack. We were having a bit of issues with Zoom, and we are going to start. And today I'm going to show you a bit of case study that we have been developing the last 3 years and what has been our lab. And then you can ask us questions. And if you want to have then a one-on-one meeting with us and see the equipment in the lab, we can take you there and show you probably tomorrow. And we haven't brought here all the equipment. It would have taken just a week to disassemble all the things that we have in the lab and bring it here. And also we have a lot of health and safety things because most of the equipment that we have need to be wear. So today I'm gonna show you a bit what has been our history, where we came from, where we are going to, and what we have been doing so far. So this is a new presentation. I haven't tried many jokes on this. So if they are not nice, tell me later so I can change it and swap it for the next time. So we started this path in 2018 when I just arrived there at Massey University. And back then the lab was me and my office. We used to have a single virtual reality headset. And to run it, I had to bend the rules. I actually didn't know that the rules was not to modify any existing Massey computer. So I bought a 1060 graphic card, put it on a 4-year-old computer, and then I was told that's not according to the rules, but the mess was already done. And that's why we start virtual reality. And we did the first study and it got even published. So I think Massey will be forgiving with me in the future. Then the year after, we start purchasing more toys. I showed them capabilities and we start purchasing more and more. And so something, the dream became bigger. They gave me a bigger space. It was not just a lab, but it was a bigger room. So I was sharing the space with the students coming from Europe. And then the year after, it started becoming a lab. We start having a real physical space. And the lab doesn't mean just equipment, means also and especially people. In fact, we had 2 new staff joining us. Zenon, that is behind us, is the guy that is helping here. Is not a technician, is a guru of many technology. And Daniel, that is online with us, is a close square contact. So it's better if he's not with us. And then the guy there that looks like Einstein, we test him, is not related. It's our lab technician, it's Chris that is here. And it's helping us developing our dreams from a research purpose. After 2020, we had to stop. Basically, we were ready to take off. Daniel and Zenon were just arrived and we went to lockdown. And the year after, we were about to take off again and we had another lockdown. So it's quite funny because whenever we purchase something new or we have a new experiment coming on, the lockdown is starting the day after. And Zenon can tell, we were starting with this experiment last year and we stopped. So it's probably our responsibility that we bring bad luck for the country. We have been doing a lot of teaching. We started with the basic teaching about BIM, and that's used to be the old version of our digital construction, the construction undergrad degree. Now with the new program, we are kind of Nutella. We are spread all over the place, and we teach digital technology from year 1 to year 3 in different courses, and we support and help different staff that teach traditional construction. We bring our digital sides. The good news is that because of all the capabilities that we have been building, we managed to start a master. And this year is going to be the first master first master trial with our master in digital built environment. And you will have the possibility still to enroll, and we are going to have 2 key papers about advanced BIM, and then we are going to have advanced application of digital construction. And it's going to be, once again, the 3 of us. So my path with my personal path with BIM started with this building. Probably you don't recognize it. It's the Auckland City Hospital. And we used this BIM during my postdoc to develop a virtual reality experience to simulate an earthquake, but not just for the sake of doing it, but because we wanted to train people and teach them how to react and behave during and after an earthquake. And this is the prototype we built. There was also an haptic system with a shaking board beside the participant. Something that we missed, it was a nice belt right here around the people too, because some of them, it was feeling that they were about to jump out of the chair, and there was a bit of health and safety constraint. And next time we will make sure that we are going to type them all around the chair to make sure that they won't fall off. I don't know if we are going to get the ethical approval for that. Well, we will see. And this was just a first step that we did. At that time, there was not much application and knowledge about how to import a BIM, a build information model, from Revit to Unity. It was a nightmare. Zenan can tell it. And the first time we did it, on the paper, on the proposal, it's super easy. You do this and you export and you import. We start running the application. It was running in virtual reality. It was running 4 frames per second. So it was like, tack, 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 not working. So we spent a couple of weeks to innovate and try to find a way to optimize visualization. Now this problem is not any longer a problem because there are many plugins. We explained this in a paper that it became really successful, almost 100 citations in only 2 years. And but now it's kind of obsolete because there is so much on the market that does exactly the same work without even thinking about it. And this is the famous experiment instead I did in virtual reality here, messing with the hack computer, the famous hack computer. So we didn't even have a laptop, and this was a section we did in a company. So we were basically going with a computer in the office of people to test it. And this is just an example in one of those showcases that we did. But the exciting part, it wasn't about the technology. What we did in this study was to compare what was the information that people were learning and retaining through virtual reality. So this was the score that people got before doing the training. We were asking them if they knew how to use a fire extinguisher and what they knew about it. Then we repeated the test after. So we asked them again. So now that you did the training, and we did the training with this virtual reality application, and the control group was doing the training using just a YouTube video that explained you how to use a fire extinguisher. And you can see here that the difference is not that big. You can see that the VR was slightly better than the video training. So it seems like, probably, yes, fancy, nice, but we shouldn't care about it. The good thing is what happened after 3-4 weeks from a research perspective. And generally people look at this part and say, oh, no, let's do it again. So this is the exciting things that we discovered. No, oh, okay. But eventually you can see that this is what happened with the video training. Significant drop. And this you can see what happened with the virtual reality. Marginal drop of knowledge. And this is one of the first examples where we provide around the world to show that virtual reality training for safety purpose is much, much, much better than traditional way of training. And we are trying to expand on this idea. For instance, just today we submitted a Marsden proposal to expand on this idea and try to make much advanced study with more control group and more longer longitudinal study. So there is a lot excitement behind this paper, and we will see what we are gonna get out of this. Probably $0, but the passion is gonna stay there. This is another example that we start doing because we are in the School of Built Environment. Come on, Rino, let's do something about construction. And here we repeated the concept, and we built here at Massey University with just one master student, a construction site in virtual reality that is helping you through the simulation to detect all the excavation hazard. So there are different parts of this application that train you about identify the hazard and learn what you should do and what you shouldn't do. And at the eventually at the end of the application, you will receive a feedback and a report if you passed or not. And we repeat using the same technology. And by the way, we use this nice headset that wasn't required any longer to be plugged with a computer. It's basically something that you put in a box and you go everywhere. And the student went to different construction site and they did the experiment. And what we observed here is that they definitely managed to do a better test in identification of hazard before and after they managed to identify those hazards in virtual reality. The things that we observe is that the knowledge went up. The things that we didn't like with this application, that the retention was like dropping right after. So this is a question mark that we have tried to identify why this is happening. Zenon expanded on this research, and they even managed to do a comparison with the traditional training. So soon we are going to start comparing the results and writing about this. This is something that you should be familiar with, Orewa. Probably most of you have been there with your kids, having nice food, swimming, surfing, right, Mustafa? Yeah, sure. And the things that we are missing here, that is the perfect scene for a big disaster. The problem is that a lot of places like this are really in hazard if there is a tsunami, because there are not really high ground places. And what we think about, and this was a project run by Zenon, it was to use the cheapest technology that we can have to build a virtual reality 360 picture scenario. And you can see here the location, all the place where the poor Zenon had to go with this 360 picture camera and take shots. And this is from a user experience, what people and participants are gonna look at. He's gonna start his experiment soon. He developed this project with a PhD student from University of Auckland. He can give you more details. And this is what you will observe in the virtual reality headset. So different option, and if you take the wrong one, you will see that you are gonna start receiving message, this is not the way. And so this is something pretty cheap that can be applied in any kind of town. This is just a proof of concept. He managed to write a really brilliant paper for CIB. And we didn't start the experiment because he got all the voucher for the participant, and the day after we start with the lockdown last year. So the bad luck of the digital built environment with COVID, but we will be back. Augmented reality, this is one of the slides that Monty showed you. And this was one of my first prototyping that I did. At that time, there wasn't much available. And when I showed this video to my friend, he told me, ah, nice, you bought a 3D printer. He thought that it was something real. And that's the things that you wanna do with augmented reality, try to develop something that looked real. In the lab, we are working with a lot of new technology that is out there. We did some experiments, for instance, using Augin, showing that you can be more quicker in detecting mistake in a construction site or in a room if you use augmented reality instead of using drawing and PDF printed out of a BIM. Maori, we haven't forgot about them. So we are using all this technology and 3D scanning to do 3D visualization and 3D scanning of Marae and Farenoi, especially when those need to be demolished for some reason. So the technology that we have in place, either using 3D scanning, and this is an example of a 3D scanning that has been converted in a 3D model in a mesh, easy to be seen in virtual reality, or using photogrammetry. It's something that we are doing and try to expand with our new prof, Regan Potangaroa, and try to make sure that we keep this information. And this was something really key when Notre Dame de Paris burned down, because there was a scientist that was doing a 3D scanning of the structure. Now we have the exact information of what we need to rebuild, if we want to rebuild as it was. This is another crazy idea from our friend Daniel, the close contact. And Daniel is thinking about how to combine drones and virtual reality to do inspection in real time or after you do the inspection with the drone. And this is the pipe floor, the pipeline that he has been conceptually building, and we are trying to develop this with his seeding funding from Marcy University. And this is something that we managed to do here. And of course, COVID started again last year. This was just a small flight. The first flight we did with a toy. It's $1,800 drone that we bought. And it was a pretty windy day. So you can see that the image is pretty stable, no matter it was a really small drone. And we managed to do a flight with that during that windy day. So that's something that we are going to start doing. Probably as far as we can, we will do a 3D mapping of the full campus. It will take us probably 1 hour of flight and 1 night for the computer to process all the data. It's something that is becoming super doable. And this is the last case study that I'm showing you. Those results are pretty fresh. No one has seen them before. So, so Azure Kinect. This is what you can do with this smart camera. They are capable to detect humans straight away, body posture, and distance between them. You can add a lot of analytic on them. And so the application can be really, really good for COVID, to social distancing. Back then, when I built that image, we were with the 2 meters. We can change the parameter and tune for 1 meter. Identify if someone is doing something silly in a construction site automatically, and do crowd dynamic study, even to identify many people are using a facility, if we need to do any change because there are too many people. And it's much more effective than traditional video recognition and people recognition through video or image, because you have a 3-dimensional information. And this is an example of what we did. This is a software built by a PhD student from University of Auckland working with us. And this, you can see that was the recording on the left. Those are point clouds, live point clouds. And the white are the bones detected of the people. So in real time, you can detect how many people are in a specific area. You can make a calculation of their speed, the density of people. And this is something really important for crowd dynamics, because we try to. This is the student talking over. Sorry, I should have put the audio off. And what we did to validate this technology, it's that we repeat the study. We took the analysis through the software, and we repeat the analysis, because we did a 360 video of the same experiment. And we try to see if someone doing manually the calculation with, of course, an Excel spreadsheet, and the software data were matching. And this is the first time I show these results. You can see that there is quite a lot of matching. You can see that there are still some outlier here that we need to figure it out why this has happened, because apparently with one of the 2 technology, I can't see because I need to move this away. Where is the information? Okay, the Kinect is the blue. You see that here the Kinect has a value that is a bit slightly higher than what was the detection in the 360. But it's showing us that pretty much the trend is close to each other. There is a bit of adjustment to do, but we are not doing bad. So this is pretty much an overview of what we are doing in the lab. We are developing more and more and more. And for instance, regarding the Marae, we are trying to recruit a PhD student from Italy to expand and also start doing photogrammetry underwater, sorry. And virtual reality, we are trying to expand, and augmented reality, we are trying to expand and use augmented reality also as a training tool and use it to train people for health and safety and do many other crazy things. So I hope you enjoyed the presentation. If you have any question or for me, Daniel or Zenan, you can ask us now, or if you wake up tonight at 4 a.m., don't call me, but send me an email. Thank you so much. Okay, let's see on the chart. Ahaha. Okay. Yeah. I'll repeat the question so people can listen here. Yeah. I repeat the question. Michael is asking here, do we need really to bother to develop application because we are not computer scientists and there is a lot of investment in developing the software, and then by 2 years it's going to be already obsolete because someone from USA is going to develop something similar or even better. And that's a really good point. Thank you for the question. That was the main mistake we did in the earthquake training tool. We spent way too much time in developing instead of using a recycle something that it was already out there, but it was something that was funded for that purpose. And then we discovered that we wasted a lot of time for that, and then don't squeeze as much and ask me, because developing prototype is not really research. It's could be research if it's something completely new. And that's why when we did the fire extinguisher training, we didn't develop it. We tried to take something that was out of shelf, and we had the application developed by some Canadian and a couple of Canadian company. Let's go back. It's not fair to say some because they give us the software for free. And what we did, in this case, it was a software developed by Mammoth and Hone. What I did with them is to contact them and say, can we use it because we have this plan to test the virtual reality application, and we got it for free. So we skipped all the developing part. For this software, instead, that it seems like we did the mistake once again. We did it because there was nothing out of the shelf available for excavation, health and safety. But in this case, it took us only 2 months of development, so it was relatively quick. The case study of the hospital, it took us more than 1 year to figure it out how to do it. This was quick and done just one person and didn't cost $500,000 to the government. Instead, there are other prototypes that I would like to develop, but I'm always thinking in that philosophy, not to do something too big, but just small proof of concept that might work. And then whoever wants to develop and expand it, they can do it, because we are not a software house and we don't want to compete with Microsoft and stuff like that, but just provide knowledge that can be applied for future development or shown people that this is working better than this other solution, rather than try to do something so big, so fancy that no one is going to use eventually because it's going to be obsolete in 1 year. Does it answer? Collaborating, and that's what we try to do. Sometimes it works, like for the Azure Kinect, we have been trying with the 3D camera, we have been trying to work with them. Sometimes they are keen, sometimes they are not keen, but we are always asking people that do development to get involved. And a company that is really supportive in this is Flame, and they develop virtual reality training. for fire extinguishers, and they are keen to receive things and develop things for us, and it's something good because they get marketing, we get research output, and everyone is happy. That's definitely another way to go. Any other question?
I think there's a question.
Yeah, we can open here. Thanks for the great presentation. Thank you. Have you got question on the?
Yeah, so that's a first question. Is there a limit to the application of AR and VR, and what issues will affect its clarity?
Then, do you want to get this? I'm here though. And also Daniel can answer on this one because they have done much more VR experiment than me. I'm relatively old now. The question is about if there is any limit in the development of virtual reality and augmented reality application, or we can do anything without any limits. And probably what I will start discussing is motion sickness.
I will just speak something about the VR. Oh, the camera is here. Sorry. So for VR, like Rino mentioned, motion sickness, and also VR is not quite friendly for people who wear glasses. And another part is that most of the VR applications right now, they only have visual simulation and also sound effects. But if you want to introduce more other sensations like, I don't know, smell, touch, or movement, body movement, it's very challenging. We can see some treadmills that have been integrated with VR device. You can just walk or run in place. But I haven't tried that before. You tried, right? It's terrible. The experience is still terrible. So I know like Facebook changed its name to Meta, and it looks like very interesting in the future, but there's still a long way to go.
Yeah.
Yeah.
Probably reselling something that is already existing. It was called Second Life. It was on a desktop. They're gonna put it on virtual reality, rebrand it as a metaverse, and it's gonna squeeze more money out of people's pocket. But it's something that we already had 20 years ago. I was playing with it.
Yeah, speaking of that, 20 years ago, we also had the movie Matrix. So I think the ultimate version of VR should be a plug into your spine, right? But I don't think it will happen in the next 20 years.
And augmented reality instead, the main limitation now is from a hardware point of view because we don't have enough powerful chip and batteries to run really advanced augmented reality application. Even the field of view, if you see a video of Microsoft HoloLens, it seems like you're submerged by holograms. Then you wear it and you see that the field of view is really nice, it's really tight, and it's a bit disappointing. It's something that we need much more. Daniel, would you like to answer about that? Because you did also a lot of experiment in VR. Are you there, Daniel?
Can you hear me?
Yeah.
The problem is I'm getting feedback, audio feedback from the room there.
It's still, I'll put myself on mute.
Okay, yeah, can you hear me? All right, it worked. No, I don't really have anything more to add. I was thinking when you were talking about AR, I think one of the other issues could also be the limited equipment or the capabilities of equipment we have currently. So, for example, for markless AR, which is a subcategory of AR where we don't need physical markers, so we're gonna be using GPS coordinates and photogrammetry processes to overlap digital objects or the augmentations on top of real world input. That process is not very much developed yet. So the alignment of the digital animations on real world views is not very precise yet. It's not very accurate. So having a VR, AR experience in real time, for example, at the job site, that's a bit difficult, I think.
Exactly, long way to go. Long way to go. Do we have another question or? That's, there is something more in the chat. There is a true to Daniel. Yeah, of course, you were talking. Okay, thank you so much. And thank you for having us. And if you have any other question, you want to see some of our toys, we will spray you with anti-germ and bring you to the lab. Thank you.
Thanks everyone for your participation. Tomorrow starts at 9 a.m. for registration. And in the afternoon, we'll have a site visit at a construction site on campus here. One of the requirements is that we wear closed shoes. We'll provide you with head hats, high vest, and glasses. So please come ready for another interesting session. Thanks everyone for your contributions today.